Welcome to our math class. Today we're going to discuss angles and angle measurements. Let us be guided by the following objectives. First, determine correctly an angle in standard position and a quadrantal angle. Second, draw accurately an angle in standard position and a quadrantal angle. And lastly, we're going to differentiate the two angles, the angle in standard position and the angle in a quadrantal angle. We know that in trigonometry, angle is treated differently than in geometry, because in trigonometry, angles will be discussed in a different perspective. Angles will be thought of as an amount of rotation generated when a ray is rotated about its endpoint. Hence, it is necessary for us to label the sides of an angle. Take note that in geometry, angle is only defined as two rays with a common endpoint, and that common endpoint is called a vertex, and the two rays are just simply called the two rays. But in trigonometry, we treated an angle in a different perspective, because it is said that it is thought of as any amount of rotation generated when a ray is rotated about its endpoint. Hence, we have this illustration of our angle in trigonometry. For example, so we have this initial position of our angle, which is called the initial side, and when we rotate our angle and move its terminal side to either direction, it's either in the counterclockwise direction or in the clockwise direction. So we always have to remember or bear in mind that we have to always put into consideration the initial side and the terminal sides which we use to rotate. Let us have some examples of our angles in trigonometry. Take note that when an angle is rotated in counterclockwise rotation or direction, the measure or the degree measure of that angle is positive. So take note, when it is rotated in counterclockwise direction, the measure of the degree of that angle is positive. When it is rotated in a clockwise direction, then the degree measure of that angle is negative. That's what we have to always remember. If it is counterclockwise, then the degree measure of that angle is positive, and if it is counterclockwise, I should say, when it is clockwise direction, then that is the degree measure of that angle is negative. Let us have some examples of our angles in trigonometry. For example, this is our initial side, and we rotate this terminal side to this half of this 90 degrees. Therefore, we have positive 45 degrees. Take note, we rotate our terminal side to a counterclockwise direction. Next is, we have 90 degrees positive because we rotated it in counterclockwise direction. From this initial side at the positive x-axis to the positive y-axis, then it comprises a 90 degrees degree measurement. And when we have a straight angle, that is from the positive x-axis counterclockwise direction, therefore we have 180 degrees positive. Another example, say we have 315 degrees, so we have to illustrate our Cartesian plane, coordinate plane. Then we know that this is 315. The half of this revolution of this angle is 180. This is 270. How much do we need to make 315? Yes. So if we have 270 plus 45, therefore that is 315. So we have this terminal side here, which is our the stop point of our angle from this initial side at the positive x-axis, we rotate to this terminal side, then we now have the positive 315 degrees. Again, we started at the positive x-axis, then we rotated counterclockwise. How about the 420 degrees? The 420 degrees, take note that the one complete rotation or revolution of the angle is 360 degrees. Now, how much do we need to have 420? So, this is 60 degrees plus 360 degrees. Therefore, we have 420 degrees. Positive 420 degrees of our angle. So, this is our initial side at the positive x-axis, and this is our terminal side at the in between these two axes in the first quadrant. So we have 420 degrees. Let's have another example. This is negative 180 degrees. There is no indication where to start our initial side. So if there is no indicated starting point where we will illustrate our angle in trigonometry, so we always consider the positive side of the x-axis. So if it is negative 80 degrees, therefore we start at the positive x-axis, we just have to have a different rotation. Take note, if it is negative, it tells about the direction or the rotation of our terminal side in the clockwise direction. So if it's 180 degrees and it is negative, then we start at the positive x-axis, we rotate at the clockwise direction to this negative x-axis. Therefore, we have negative 180 degrees. How about negative 405 degrees? Take note, this is negative, therefore, the rotation should be in clockwise direction. So from the positive x-axis, the complete rotation is 360. Take note, that is 360. How much do we need to have 405 degrees? So 360, yeah, that is 45 degrees. So we extend more our terminal side rotation to this in between the x and y, positive x and negative y axis, in between, because we know this is 90 degrees, half of this is 45 degrees. So this is 360 plus 45, and therefore we have 405 degrees. Another example. Take note, if we have this kind of example, in number 8, we have here negative 90 degrees. How does this happen? Okay. Yes, this is negative 90 degrees because the angle is from the negative x-axis to y, positive y-axis. This angle measure is exactly 90 degrees. Why is it negative? It is negative because of its direction of the rotation of the terminal side. Okay, so if it is clockwise direction, that signifies a negative sign of our degree measure. Okay, but the only difference is it started its initial position or its initial side at the negative x-axis. Take note of that, and its difference from the other examples. Another, in number 9, we have negative 270 degrees. We know if we start from here, the positive side, we will have here. But this is the other way around. So we started at the negative x-axis. Still, we ended up at this point, at this array, or at this axis, negative y-axis. But our rotation is in clockwise direction. Therefore, it is negative 270 degrees. Another example. We have the complete revolution of our terminal side of this angle. We know that the complete revolution or the complete rotation of our terminal side from, that makes a circle. This is 360 degrees. Why? Why it is also negative? Okay, this is 180 plus 180 is 360. This is negative because of its direction of the rotation from the it is clockwise direction, therefore it is negative 360. The only difference is that it started in the negative x-axis. If we're going to look back at the other examples, okay, from number 1 to number 7, what can we say to these angles? What can we say to these angles? Take note that these angles from number 1 to number 7, these angles' initial side is at the positive x-axis, and all of their vertices are at the origin of the Cartesian coordinate plane. It is at the intersection of the x and y axis. So when its vertex is at the origin of the Cartesian coordinate plane and the initial side started at the positive x-axis, therefore all these angles are called angles in standard position. Take note, we only consider angles to be in standard position if and only if its vertex is at the origin of the Cartesian coordinate plane, meaning to say, its vertex is at the intersection of the two axes, the x and y axis. Now, the x-axis and the y-axis, their intersection is the vertex of that angle. Therefore, that is in standard position. Another condition, an angle to be considered to be in standard position if its initial side is at the positive x-axis. How about numbers 8 and 9? We might think that these angles are examples of angles in standard position because first condition is their vertex is at the origin of the Cartesian coordinate plane. But the only thing that these angles are not considered to be in standard position because their initial sides start at the negative x-axis. Therefore, numbers 8, 9, and 10 angles are angles not in standard position. Okay? So, the angles in standard position are angles whose vertex lies at the origin of the Cartesian coordinate plane and its initial side lies at the positive x-axis. Another, look at examples 2, 3, 6. Look at examples number 2, exactly 90 degrees, 3, exactly 180 degrees, 6, exactly 180 degrees. Okay. These angles are said to be in standard position, and at the same time, these angles are called quadrantal angles. Why? Because aside from the fact that these angles are in standard position, meaning to say their origin lies, or their vertex or vertices lie at the origin of the Cartesian coordinate plane, and their initial sides are at the x-axis. Another condition that we have to consider for an angle to be a quadrantal angle is that its terminal sides always lie at the x or y axis. Take note, for example, in number 1, we have here 45 degrees. Its terminal side does not lie at the either x or y axis. Therefore, this is not quadrantal, though this is in standard position. But what about in number 2? This is a quadrantal because It is in standard position, meaning its initial side is at positive x-axis. The vertex is at the origin of the Cartesian coordinate plane, and its terminal side lies at the y-axis. Okay? How about in number 3? Its terminal side lies at the x-axis. So either way, when the terminal side lies either at x or y-axis, and its initial side always at the positive x-axis, therefore that is a quadrantal angle. Number 4 is not a quadrantal angle because the terminal side does not lie at either x or y axis. How about number 5? This is again a angle in standard position but not a quadrantal because its terminal side does not lie at either x or y axis. But in number 6, though it is negative 180 degrees, but take note it started at the positive x-axis, the vertex lies at the origin of the Cartesian coordinate plane, and its terminal side lies at the negative x-axis. Therefore, thus number 6 is still a quadrantal angle. Number 7, the terminal side does not lie at either of the x and y axis. This does not make a sense at all to be considered as quadrantal angles because these angles are not in standard position. Therefore, these angles are not quadrantal. Okay? I hope you understand and have learned something from this discussion. So what do you think is the difference of the two angles? The angle in standard position and the quadrantal angle. Then what do you think or how do we draw or illustrate an angle in standard position and an angle in and a quadrantal angle, I should say? Very good. We have to always start at the positive x-axis. Take note that our vertex should always be at the origin of the Cartesian coordinate plane, meaning to say at the intersection of the two axes, the x and the y axis. Then, where the terminal side goes, that is still an angle in standard position. Whether it goes to positive x or it goes to any axis or in between the two axes, that is still an angle in standard position as long as its initial side is at the positive x-axis and the vertex is at the origin of the Cartesian coordinate plane. How about in the quadrantal angle? The quadrantal angle is considered to be a quadrantal angle if and only if, number 1, that angle is in standard position. Number 2, its terminal side should always lie in either x or y axis. Okay, thank you very much.